Good morning students. In the last class I have discussed about the topic measurement of time as well as dimension of physical quantity. In this class I will discuss about dimensional equation. So let me discuss what is actually dimensional equation. Dimensional equation gives us those relation which relates the physical quantity with its dimensional formula. For example, what is the dimensional equation for, say, force? So how can we get the dimensional equation for force? Force means actually this is mass into acceleration, mass into acceleration. So mass, for mass, dimensional equation for mass, actually what is the dimension? M. Acceleration, actually this is the rate of change of velocity. So this is, we get L t to the power minus 2. So what is the dimensional relation for force? Force will be mL t to the power minus 2. Similarly, we can again get the dimensional equation for pressure also. So for pressure, how can we get the dimensional equation? Pressure means actually force divided by area. So for force, already we have got the dimensional equation is mL t to the power minus 2 divided by area. So for area actually what is the dimensional equation or dimension? L square. So we get this is L square. So it will be m L to the power minus 1 t to the power minus 2. So what will be the dimensional equation for pressure? It is m L to the power minus 1 t to the power minus 2. So this is the required actually dimensional equation for pressure and dimensional equation for force. In this way, dimensional equation actually relates the physical quantity with its dimensional formula. Next, after that, we will discuss about another dimensional formula. Let me discuss. So next, what is given here? Name the physical quantities whose dimensional formula are as follows. So say some dimensional formulas are given to you. So you have to reply what will be the physical quantity whose dimensional formula is this one. So in this case, actually how can we get the name of the physical quantity? So for this we will actually for this, how can we get the name of the physical quantity? Let's see what is it. Dimensional formula is, it is given mL square t to the power minus 2. mL square t to the power minus 2. So we can write this dimensional formula in this way also. mL t to the power minus 2 into L. So mL t to the power minus 2, already we have known this thing that mL t to the power minus 2 is the dimensional equation of for force. So we get this is force. Name of the physical quantity is force, and L is the dimensional equation for actually distance. This is distance. So force into distance, actually what force into distance, this will give us the name of the physical quantity. It means actually this is what is it? Work done. Force into distance means this is work done. So we get this is work. So in this way, from a dimensional formula we can come to know what is the physical quantity, what is the name of the physical quantity. Next, this is number 1. Next, number 2. Number 2, what is given here? mL square t to the power minus 3. So let's see what is this physical quantity actually. So number 2, it is given ml square t to the power minus 3. So here actually, how can we write this thing? We can write in this way, ml square t to the power minus 2 divided by t. Now ml square t to the power minus 2, this dimensional formula actually give us the name of the physical quantity. It means actually, this is the physical quantity. Already we have got this thing. This is work done. This means ml square t to the power minus 2 is the dimensional formula of work done. Already we have done in the equation, in the question number 1. So here we can write this is work done, and divided by time. So work done divided by time, this means what? The amount of work done doing per unit time, this actually we call this is the definition of power actually. So work done divided by time means this is power. So in this way we can come to know that ml square t to the power minus 3, this is the dimensional formula for the physical quantity of power. Next, what is the dimensional formula given to us? M t to the power minus 2. So let's see what is the physical quantity actually. So number 3, it is given m t to the power minus 2. So m t to the power minus 2, how can we write this thing actually? M L t to the power minus 2, since here this term is multiplied by or one new term, L is actually written here, that is why we should divide this term by L also. Then this will be become equal to the original dimensional formula m t to the power minus 2. যেহেতু ইয়াতে আমি এটা L লিখিছোঁ, গতিকে আমি L টোৰে ডিভাইড কৰিব লাগিব, তেতিয়াহে আমি অৰিজিনেল ডাইমেনশ্যনাল ফৰ্মুলাটো থাকিব, একে সেম থাকিব. So m L t to the power minus 2 divided by L. Now what is this? m L t to the power minus 2, this means this is the force. This is the force actually, and L, this means actually this is the length. So force divided by length, this means actually this is, we can write as in this way, surface tension, or it may be written in this way also, force constant, force per unit length. This is so in this way, by actually from this dimensional formula m t to the power minus 2, we can come to know that the name of the physical quantity is surface tension or force constant. This means the name of the physical quantity is surface tension or force constant. After that, number 4, what is given here actually? Number 4, m L to the power minus 1 t to the power minus 2. So how can we write this thing actually? We can write in this way, m L square t to the power, not L square here, L t to the power minus 2. So if we write here L, then we have to divide this term by L square also, then this dimensional formula will be remain equal to the original dimensional formula. That is why m L t to the power minus 2, so we should divide this term by L square. then only it will be become equal to the original dimensional formula. So ml t to the power minus 2, then this means what? This is force. ml t to the power minus 2, this is force, and L square, this is area. This is area. So force divided by area. What is this? Force divided by area. Force per unit area. This is called the pressure. Pressure. So from this dimensional formula m L to the power minus 1 t to the power minus 2, actually it gives us the name of the physical quantity. This is pressure. In this way, by observing the dimensional formula, or from the dimensional formula, actually we can come to know the name of the physical quantity. After that, I will discuss about some dimensional formula of some physical quantity. Now in this question, the name of the physical quantities are given, so we have to find out the dimensional formula. So let's see. So this time in this question, actually the name of the physical quantities are given. We have to deduct what will be the dimensional formula actually. So first, what is the gravitational, what is the here physical quantity? Actually gravitational constant. So gravitational constant, for this to find the dimensional formula, first we should know what is the gravitational equation actually. So for this, what is it? 1. Equation number 1. Already we know F is equal to Z into M1 into M2 by R square. Here Z is the gravitational constant. So what will be the dimensional formula for Z? For this, we should write in this way: Z is equal to dimensional formula of F into dimensional formula of R square divided by dimensional formula of M1 into M2, or we can write separately also, dimensional formula of M1 into dimensional formula of M2. So dimensional formula of F means this is ml t to the power minus 2. Already we got this thing. And dimensional formula of R square, this is L square divided by dimensional formula of M1 is capital M and M2 is capital M. So this will be M square. So what will be the result actually here? This will be M to the power minus 1 second. Okay, this is M to the power minus 1 L cube t to the power L cube t to the power minus 2 t to the power minus 2. This will be the this one. So in this way actually we can get the dimensional formula for gravitational constant. This is the this will be the answer of question number 1, gravitational constant. After that, we have to find out the dimensional formula for power. So are you clear how can we actually get this dimensional formula for gravitational constant? So after that, let's see what will be the answer of question number 2. So dimensional formula of power. So power means actually we can write in this way. Power is, we can write in this way, work divided by time. Work divided by time. So work means actually this is force into distance. Force into distance divided by time. So see here, power we can write in this way. Power is work divided by time. So work means force into distance and time. So now we can easily write the dimensional formula for force and dimensional formula for distance and time. So what will be the dimensional formula here? So power, dimensional formula, power is equal to, we can write in this way, m l t to the power minus 2 into l divided by time. So what will be the result actually here? The result will be m l square t to the power m l square t to the power minus 3. This will be the result for dimensional formula of power. So power, we can write work divided by time. After that again we write work is equal to force into distance, time. So for force, dimensional equation will be ml t to the power minus 2. For distance, the dimensional formula will be L divided by time. So m L square t to the power minus 3. This is the result for the dimensional equation of power. In this way, we get this result. After that, we have to find out the dimensional formula for Planck's constant. So let's see how can we get the dimensional formula for Planck's constant. So Planck's constant, actually we can write in this way, Planck's constant H is equal to energy divided by frequency. So what is the dimensional formula for energy? Energy means actually work done into or force into displacement. Force into displacement, that means the dimensional formula for energy is m L t to the power minus 2. So displacement ml square, and frequency. For frequency, the dimensional formula will be t to the power minus 1. T to the power minus 1. So it will, the result will be what? M L square t to the power minus, if we bring this term above, then the result will be m L square t to the power minus 1. In this way, we get the dimensional formula or equation for Planck's constant H also. How can we get H? Planck's constant, energy divided by frequency. For energy, actually, work done, the unit of work done is also one kind of energy. So this is means to do the work, energy must be spent. So the dimensional equation for work done and energy will be same. So energy will be, dimensional formula will be m L square t to the power minus 2, t to the power minus 1. So m L square t, if we bring this term to above, the result will be t to the power minus 1. So this will be the dimensional equation or formula for Planck's constant. After that, last question, surface tension. So surface tension, actually, how can we get that dimensional formula for surface tension? This is force divided by actually length. So let's see. Number 4, surface tension. Surface tension. This is indicated by gamma or force divided by length. Force divided by length. So force, for force, what is the dimensional formula for force? Force is m L t to the power minus 2 divided by L. So L will be cancelled. So result will be m t to the power minus 2. and this bracket must be given to here. Actually, whenever you write the dimensional equation or formula, this bracket must be given here. So result will be what? M t to the power minus 2. This is. So this time, actually in this question, check by method of dimensions whether the following equations are correct. That means some equations are given to us, so we have to check out whether these equations are correct or not by using the dimensional formula. So in this case, actually how can we check? Let's see. So for this, say solution answer equation number 1, we have to solve equation number 1. So left hand side, what is given here? Left hand side, by applying the dimensional formula, actually we will check whether these equations are correct or not. So dimensional formula for left hand side is equal to E, and dimensional formula for E is actually what is it? This is energy. E means this is energy. So energy dimensional formula is already we get work done. So force into displacement. So M L t to the power minus 2. This is L square. So dimensional formula for energy is this one. After that, right hand side, what is given here? MC square. So dimensional formula for MC square, what is it? C means here this is velocity. So what will be the dimensional formula for MC square? This will be M C for C. This is L t to the power minus 1. So L square t to the power minus 2. So M L square t to the power minus 2. So actually what is it? Left hand side, the dimensional formula is ml square t to the power minus 2, and right hand side, the dimensional formula is ml square t to the power minus 2. That means left hand side and right hand side are same. That is why this equation is correct. In this way, by using the dimensional equations, actually we can check out whether this relations is correct or not. After that, let me check out the equation number 2. Say equation number 2, what is it? T. T means actually here tension surface. This is actually tensions which is actually created in case of a simple pendulum. That is why the left hand side dimension T is dimension, we will write in this way. T, this is T, surface tension, not surface tension, this is tension generated in the string of a simple pendulum. So this is T, and the right hand side, what is it given? Right hand side, this is twice pi. So no need to find out the dimension for twice pi. There is no dimension of twice pi, so no need to write down here. Only we should write L by Z. That means dimension of L by Z. So we will write in this way. L, this is for L, and for Z, this is L t to the power minus 2. This will be half. Root, for root, we give here the power is as half. So what will be the result actually here? This will be L cancel and t to the power minus 2. If we bring this term to above, it will become t square and half. So it will be, result will be t, only t will remain. That means t square to the power half, and result will be only in this way, in the equation number 2, actually if we check out the dimension for T, tension, we get the result is capital T. Similarly, if we check out the dimension for right hand side, we get the right hand side dimension is also T. That is why the left hand side and right hand side dimensions are same. Hence we can say that the equation number 2 is correct. After that, let me check out the equation number 3. What is it? Actually, what is given here? Here phi is equal to root over P by rho. One equation is given to you where P is the pressure and rho is the density of the medium. So we have to check whether this equation is correct or not. So let's see equation number 3. Equation number 3, left hand side, what is the dimension here? Left hand side dimension of V. So dimension of V, this is actually L t to the power minus 1. Dimension of V, L t to the power minus 1. So result is L t to the power minus 1. And right hand side dimension is what? Dimension of root over P by rho. So P means actually here this is pressure, and pressure means already we got this thing. Pressure means force divided by area. So for pressure we get the dimensional formula, force ML t to the power minus 2 and divided by force divided by area. For area, dimensional equation is L square. So this will become L to the power minus 1 actually. One second. Okay, for actually pressure, force divided by area. So for force ML t to the power minus 2, force divided by area. For area we write here L square. Again for rho means actually this is written here density of the medium, that means mass per volume. So it will be equal ML to the power minus 3 actually. For volume the dimension is L cube. Since it is divided M divided by L cube, we write here ML to the power minus 3 here. Minus 3 ML to the power minus 3. So result will be what? We write here L square means L to the power minus 1 t to the power minus 2 to the power minus 2, and this is power is here half. So divided by M L to the power minus 3 and power is half. So if we bring this term L to the power minus 3 to above, what will be the result? Actually here MM cancel, L square t to the power minus 2 to the power half. So result will be what? Result will be L t to the power minus 1. This is L space actually here. We write here right hand side. This will be equal to L t to the power minus 1. Dimension is minus 1. This is the right hand side dimension, L t to the power minus 1, and left hand side we get the dimensional formula is L t to the power minus 1. That means left hand side and right hand side, both the dimensional equations are same. That is why the third equation, V is equal to root over P by rho, this equation is also correct. In this way, by using the dimensional equation or formula, we can check out whether a relation is correct or not. So I think you are clear, or anywhere you have doubt or confusion, you can ask me. In the next class, I will discuss some about new topic. So today we will finish here, or we will stop here. Thank you.